Suppose I ask you to solve the following system. To learn about inverse of matrices, and we're going to apply that. If you have a system of linear equations, ax equals to b, and if your matrix A is invertible matrix, then x is equal to inverse of A times the column matrix B. Let's make sure that focus is okay. So let us continue. We're going to form AX equals to B. A is the coefficient matrix, 2, 3, and 2, 3, 3, and 4, 1, 1, and 1. My X column is X, Y, and Z. These are the variables that we have, the variable column. And on the right-hand side, you have the constant column, which is 1, 1, and -2. Very good. So let us find the inverse of this matrix, and then just find the multiplication between inverse of A and B. Then we're done. The inverse of A, then the inverse multiplied by B is our answer. Very good. So we're going to use Gauss-Jordan elimination method. We're going to form A, and here you have I3, and our goal is to convert this into I3 and the inverse of matrix A. Step by step. Let us form the adjoining matrix. 2, 3, 2, 3, 3, 4. Just try to be careful about the algebra process. 1, 0, 0, 0, 1, 0, 0, 0, and 1. So we're going to convert this into the form that we actually have. 1, 0, 0, 0, 1, 0, 0, 0, 1, and some elements here, which is eventually going to be the inverse matrix. The very first element is 2, which must be 1. So we're going to divide the very first row by 2. Or multiply the first row by a half. And this guy becomes our new first row. So I'm going to copy this guy down here. I have a 1, 3 halves, I have a half, then a half, 0, and 0. Very good. Below 1, we must have 0 and 0. So what I'm going to do, I'm going to multiply the first row by -3 and add it to second row. This guy becomes my new second. So I have -3, -9/2, -3 halves, -3 halves, 0 and 0. I'm going to add that to the second row, which is 3, 3, 1, 0, 1, and 0. So this guy becomes 0. And here we have -9/2 plus 3, which becomes -9 plus 6, which is -3 divided by 2. This guy is -3 plus 1, which is -1/2. Then you get -3 halves, 1, and 0. So here you have 0, -3 halves, -1/2, and -3 halves, 1, and 0. Let's look at this element. It must be 0, but it is 2. So what are we going to do? We're going to multiply the first row by -2 and add it to the last row. -2 R1 plus R3 becomes our new R3. Okay. Here we go. I have a -2, -3, -1, -1, 0, and 0, plus 2 and 4 and 1, 0, 0, and 1. So this is 0, this is 1, this is 0, -1, 0, and 1. Okay, 0, 1, 0, -1, 0, and 1. Now we're going to move to the second element here, which must be 1, but it is -3 halves. What are we going to do? We're going to multiply the second row by -2 terms. negative 2/3 times R2 becomes our new R2. So this is just 1, negative 1/2 times negative 2/3 becomes 1/3. Then we have negative 3/2 times negative 2/3. As you can see, it is just 1. And this is 1 multiplied by negative 2/3. And here you have a 0. Above 1, below 1 must be 0. So we're going to multiply the second row by negative 3/2 and add it to the first row. Negative 3/2 R2 plus R1 becomes our new R1. Very good. So I have a 0, negative 3/2, and I have negative 3/2 times a third, negative 1/2, negative 3/2, and negative 3/2 multiplied by negative 2/3, which is just 1. Then I have a 0, and I'm going to add that to R1, 1, 3/2, 1/2, 1/2, 0, and 0. So it stays as 1, this is 0, this is 0. Then here I get negative 1, 1, and 0. So this guy is now 1, 0, 0. And then I have negative 1. And I have 1 and 0. So let us move on to this guy here. It must be 0. So let us multiply the second row by negative 1 and add it to the last row. Negative R2 plus R3 becomes my new R3. So 0, negative 1, negative a third, negative 1, 2/3, and 0 plus 0, 1, 0, negative 1, 0, and 1. So this is just 0, 0, negative a third, negative 2, 2/3, and 1. So here I have 0, then 0, negative a third, then negative 2, then 2/3, and 1. Perfect. So far, so good. Now, take a look at the last element. This guy must be equal to 1, but it is negative 1/3. So we're going to multiply the third row by negative 3. Negative 3 times R3 becomes our new R3. So this guy is just 1. This becomes 6. And this guy is negative 3 times 2/3, negative 2. And this is just negative 3. Now, above, we must have 0. We're good with the first row, but we have issue with the second row. So multiply the last row by negative a third and add it to R2. This becomes your new R2. So here you have 0, 0, negative a third, and here you have negative 2. Then you have 2/3, and then here you have 1 added to 0, 1. A third, 1, negative 2/3, and 0. So this is 0, this is 1, 0, negative 1, 0, and 1. So this guy is 0, 1, then 0, then negative 1, 0, and 1. So seems like we found the inverse of our matrix. Now that you found the inverse of the matrix, all you need to do is multiply that by the constant column. This is equal to negative 1, negative 1, 6, 1, 0, negative 2, 0, 1, negative 3 times the constant column, 1, 1, negative 2, and the answer is equal to the first row multiplied. We only have one column, So negative 1 plus 1, 0, and you have a 0. Then the second row multiplied by the constant column, negative 1, 0, and negative 2, negative 3. And then here you have 6 minus 2, 4, and plus 6, which is 10. So it seems like x, y, z is equal to 0, negative 3, and 10. X is 0, y is negative 3, and z is equal to 10. We can also plug this back into the system of linear equations and check to see if it's correct or not. My system is 2x, check. 2x plus 3y plus z equals to 1. So this guy says, hey, 0 minus 9 plus 10, which is 1. Of course, it is correct. It is true. Let's check the second equation. We have 3x plus 3y plus z. This guy must be equal to 1. Well, here I have a 0. I have 9. And here I have a 10, which is, of course, equals to 1. And my last equation says, hey, I have 2x plus 4y plus z equals to negative 2, which, let's plug those in. I have a 0, then I have negative 12, and here I have plus 10, which is negative 2, which is correct. So we found the solution for this system.